All right, so we'll just give it another minute here, and
Right.
then I think we'll go ahead and start. Um, if you just joined us, this is the Chameleon webinar featuring Bogdan Stoica, who's going to be going over artifact evaluation. I'm going to give a little bit more of a formal introduction once we get started. I'll just repeat if at any point during the presentation you want to ask a question, you're welcome to type your question in the Q&A panel, which should be located at the bottom of the Zoom application screen. Once we in the presentation, we open up for open discussion questions. You can also use the raise hand function, which is also on the bottom of the application uh, to raise your hand, and then I will unmute you and allow you to ask your question. And with that, I think we can go ahead and get started. So, good morning, everyone. Um, good afternoon, good evening, depending on where you're joining us from. Welcome to today's Chameleon webinar on how to conduct artifact evaluations on shared infrastructure. My name is Mark Richardson. I am a technical project manager with the Chameleon project, which is led by PI Kate Cahey from University of Chicago and Argonne National Lab. Before we dive in, I just want to mention that this is part of an ongoing webinar series that the staff at Chameleon, are hosting. If you're interested in other topics, you can find recordings of past webinars on our website at chameleoncloud.org. You can also sign up there for upcoming sessions. And next month, we'll be hosting a webinar on our edge computing platform, Chia Edge. So stay tuned for that. The registration link is already up on our page, and I'll put that link in the chat once I turn things over to Bogdan. So I'm very pleased to introduce today's speaker, Bogdan Stoica. Bogdan is a postdoctoral research associate in the SysNet group at UIUC. He completed his PhD at the University of Chicago in 2025, and Bogdan brings very deep experience participating in and helping run artifact evaluations for numerous conferences, including OSDI and EuroSys. He received the Distinguished Artifact Evaluator Award at EuroSys 25 and is currently and will be serving as the co-chair of artifact evaluation for EuroSys 26. And today he's generously agreed to share practical insights on how conference organizers can leverage public testbeds like Chameleon to make reproducibility more accessible for their communities. Here's how today's session will work. I'll hand things over to Bogdan for his presentation, and then we'll use any remaining time for discussion and Q&A. For questions, you have two options. You can type your question in the Q&A panel at the bottom of your Zoom window. Just click the Q&A button in your toolbar. Or if you'd like to ask a question live, which would be at the end of the presentation, you can use the raise hand function that is also on the Zoom toolbar at the bottom. One quick housekeeping note, we will be recording today's presentation and post the video online afterwards. However, we will stop recording during the Q&A section to give everyone more freedom to participate. So with that, Bogdan, I'll turn it over to you.
Thank you, Mark, and thank you for the introduction. Thank you guys for joining. I know some are joining around midnight or evening time, so I really appreciate taking the time to listen to us talking about artifact evaluation and more broadly reproducibility in research and how platforms like Chameleon can help us get there. The kind of information in the slides and in this webinar has been collected over several years, and of course spans my time at UIUC, but also time that I spent at U Chicago during my PhD. That's where most of my reproducibility and artifact evaluation work has been done. And of course, my efforts are generally sponsored by, Chameleon Cloud with compute credits, and Microsoft Research with AI credits and mentorship. So with that good note, let's get get started. I'll start my clock here. I'll try to, wrap things up in about 35 minutes so everybody can get a chance to ask questions. But if you want to ask questions in while while I talk, feel free to interrupt and raise your hand and ask your question. I'm more than happy to answer this. Actually, usually webinars are a kind of a two-way street, so it's awkward if I just speak here in front of my screen, not seeing everybody. So, right. Without further ado, let's dive in. I'm sure I'm not saying something new to many of you here, but just to kick things off, this is the typical workflow of systems research. Usually you come up with the idea, you have some hypothesis, you build a tool, and you analyze and evaluate that tool and produce some results. And of course, your tool nowadays has to have some AI component. And then you go and write a paper about it that hopefully becomes a classic like this one. This is for systems research or for research that is on more of a practical side. For theory, things are a little bit more different, but this is basic. This is a very typical workflow. And now, if you want to have your ideas put to the test, what you do, you come up with the idea, build the system, evaluate, and then write the paper and submit it to a conference to be peer reviewed. And you wait for a few months for the peer review process to take hold. And then at the end of this process, you would basically get a decision, a paper notification of acceptance or reject. Some conference have revise or resubmit, of course. But basically, those are kind of the two outcomes that can happen. And this has been the status quo for a few decades. But around 15 years ago, I would say around 15 years ago, this peer reviewing process has been amended. And nowadays, it's fairly common to have an extra stage, which is called artifact evaluation. Now, what is artifact evaluation? And I promise this is the only slide where I'll throw a lot of text at you. The rest are just animations. But just to get on the same page and have a shared definition, the artifact evaluation is the process of checking that the artifacts, the prototypes released with the research paper, which means source code, datasets, benchmarks, scripts, configuration files, and the whole shebang. They faithfully correspond to what is written in the paper, and then can be used by independent folks to reproduce or at least substantiate the main claims of the paper, the experimental setup used, and the reported results. So, in other words, if you claim something in the paper and you're encouraged to release your tools that help you go from hypothesis to conclusion, and then somebody can replicate your process and reach the same conclusion. That doesn't mean the same numbers, but it has to be the same conclusion. So like I said, status quo was just the peer review process where the papers were being reviewed, and about 15 years ago, this kind of mindset shifted towards adding evaluation component or reviewing component for the prototypes themselves. As far as I can dig up on your favorite search engine, I used Bing. Maybe that's the problem. The first artifact evaluation that I could find was conducted at FSE 2011. That is a software engineering conference called Foundations of Software Engineering. It was a pioneering work. Sadly, there are not that many details about how many artifacts were evaluated and what are the prototypes and whatnot. And of course, it looks different than what it is today, but it was the first. And since then, there are a few more, the conferences have been adding this process more and more. 2 years after that, the programming language community added an artifact evaluation component to their peer review process. I believe the first one was OOPSLA. And then a few years later, the security and privacy community, and finally the systems community with SOSP 2019. And since then, a bunch of other conferences have been implementing this artifact evaluation process, and nowadays it's fairly common. If you submit to a conference, it's rather unusual not to have artifact evaluation instead of having one. And of course, other communities are continuously adding artifact evaluation to their peer review process. Computing architecture now has, at least for their main venues, has artifact evaluation, AI and machine learning databases, and recently cryptography. And every year there are new conferences that implement this. For example, this year, as far as I know, there are a few conferences, one of them notably NSDI. NSDI is implementing artifact evaluation for the first time. So it's an evolving process, and we're very happy that people take reproducibility seriously. I saw there was a raised hand. I don't know if there was a question, but if there is, Mark, please let me know. If not, I'll just continue.
Looks like someone may have done it by accident, so I think you're good.
Yep, no worries. Don't forget, you can stop me at any time. Right. So, what are the goals of artifact evaluation? Like broadly, why do we run artifact evaluation committees and put both authors and reviewers through this whole process? Well, the first and foremost goal is to increase trust in published research, and reward those papers that go the extra mile to make their artifacts or their prototypes available and reusable and reproducible to the community. And each paper receives what we call artifact badges, which are check marks, essentially, that this paper not only is peer reviewed, but the results can be independently reproduced. Of course, we also want to ensure that the prototypes themselves are available and easily accessible. It used to be the case that, and it still is today, but at least for me, it's difficult to keep track. It used to be the case that you would cite or send the reader to a website where you upload your prototype. This could have been GitHub. More recently GitHub, but could be any other hosting site. But you had to dig through the paper to actually figure out where the prototype is stored. Having a separate peer review process also brings or gives more visibility to those artifacts and collects them on one website on the conference, one page on a conference website, and makes them more easily accessible to the community. Of course, we want to facilitate and enable reproducibility of the core claims and key findings of the paper. That's always, that's always a goal for us as a community, because we want to build on top of each other's research and compare with each other, and that's how we push the boundaries of knowledge by understanding the status quo, understanding the state of the art, and being able to faithfully compare with the state of the art. And this helps us get there. And of course, if others want to reuse or extend your artifact either for research or for, in their more practical work, maybe run your open source prototype that finds bugs, for example, in their on their code base, and find bugs in their code base using, your research prototype. It's nice. It's always nice when your prototype went through artifact evaluation, because people have at least a bit more certainty that this is reusable and easy to extend and documented. And right, so these are kind of the broad goals, and that's how each that's how we start artifact evaluation process for at least the conference that I participated with these four goals in mind and try to achieve them the best we can. The outcome of artifact evaluation is stapling badges on papers, which are check marks that confirm this particular paper has gone through a rigorous peer review, an extra rigorous peer review process, and their results, their main claims have been reproduced by a set of independent reviewers that have no connection with the authors. There might be variations between conferences, but originally there were a few badges. If you publish your artifact on a permanent storing service or hosting service, you get what is called the artifact available badge, meaning that anybody can go and access your artifact, and that would be stored permanently and persistently in the ACM digital library. And then you have badges for whether or not your artifact is usable. A badge if the artifact is functional, which means it's documented and exercisable, and it has some scripts or some process to validate the results. And you get an extra badge, like in this case, if your artifact or prototype is repurposable, it's modular and can be easily extendable, and you have documentation that explain to others how they can build on top of your artifact. And there are also badges for when other folks in the community can re-obtain your results. You have results reproduced, which means that these results have re-obtained by using partially author-provided scripts and artifacts and guidelines. Think of it as, maybe this could be as simple as following a README or reading an appendix to a paper. And then the last badge, which is the most powerful, is results replicated, which means that an independent set of community members have reobtained your results without any author-provided artifacts. So they're able to re-implement your infrastructure from scratch and then just run the tool you provided without reading the documentation or guidelines, and results are replicated. Not the same numbers, but again, very close and following the same trends as in the original paper. And some conferences, award up to 5 badges. Some conferences award just a subset. Today I'm going to talk only about systems conferences because that's what I'm familiar with, and that's where I join most of the artifact evaluation committees. For systems, things are a little bit more simplified. We offer 3 badges, whether or not your artifact is available on permanent storage, whether or not your artifact is functional, so I can download it. I can clone your repository or download, and it's documented fairly enough to I can run, build and exercise a bit of its functionality. And then finally, if I use or follow the guidelines that the authors had put forth and I use their scripts and whatnot, I'm able to reobtain the results. We don't yet offer the results replicated badge, but maybe in the future there are discussions to make it even give extra credit to papers that can be independently replicated without any guidelines from or handholding from the authors. Right. So how does a typical artifact evaluation timeline looks like? Remember, this is after the paper has been accepted through a peer review process. So you submit to a conference, you get the notification that you get accepted, and then you get another notification saying that, hey, you're invited to participate in artifact evaluation. And although it's, sometimes, or although it's optional and people are talking to make it mandatory, we have a very high participation rate of around 70%. So around 70% of the papers are actually going to this extra peer review process to have their artifacts validated by a separate committee. So once after paper notification, if authors want to go through this extra peer review process, they would register their artifact just like they register their paper, and then they would submit their artifact to the committee. And this would kick off the evaluation stage of this process, which, of course, for those of you who have been part of a program committee would know, starts with bidding, which means that committee members would read or sift through the papers and artifacts and point to those that they want to actually review based on their expertise or preference, or whether or not they find it interesting. And then once the bidding ends, we have an algorithm to match papers to reviewers based on their preference. And when reviewers are assigned to papers or artifacts, or the other way around, the artifacts are assigned to reviewers, we start what is called kick the tires. The kick the tires phase is something where we encourage both reviewers and authors to communicate with each other and make sure that there are no broken links. You can git clone. There are no missing scripts that would install and build your artifact, or there's no hidden dependencies that haven't been described in the README file or in the paper. And essentially, in this stage, what we encourage reviewers is to take one experiment, or we encourage authors to provide reviewers one small experiment that they could run end to end. This might not validate the entire set of claims that the paper makes, but at least a small subset, and it should be reasonably quick, a few days. And this is meant to make sure that there are no discrepancies or missing or broken dependencies or missing documentation, missing guidelines and whatnot. So once this stage is done, reviewers are encouraged to get on with the main evaluation and reviewing, where they actually go and exercise the entire functionality of the artifact, and they try to reproduce the figures, the tables, the measurements, the results of the paper, and then they're encouraged to use their best judgment to see if what they observe matches what the paper claims and what the paper shows through the graphs, the plots, the tables that are in the paper itself. And once this is done, a few weeks later, authors get notified of a decision, just like they would with the paper. And the decision here is, those check marks, those badges that I just talked about, based on the quality of the artifact and how far along in the evaluation the reviewers have managed to get. They get a subset of those 3 badges: available, functional, or results reproduced. And of course, at the end, and this is something that has been happening, it's fairly new, but it's happening to more and more conferences. What committee members do is write a public summary of the reviews and their findings and publish it along with the artifact. So along with their decision and badges that the artifact or paper has got. So it's for those of you that submit to machine learning and AI conferences, you're familiar with the concept of open review. This is exactly what it is here. Right. So it's a fairly long and complex process involving, not only authors and reviewers, but also a lot of back and forth and communication between the 2 groups. Usually the preparation stage takes about 1 to 2 weeks, but the evaluation stage could take up to a month, 4 to 5 weeks, 4.5 weeks, something to that effect. Right. So in this process, authors and reviewers have different roles, but they're encouraged to talk with each other and communicate as often as possible. The role of authors while they're preparing the artifact is to present to reviewers a self-contained prototype which is hosted, which is stored on a persistent hosting service. Um, Although GitHub is fine, you all know that you can rewrite history with GitHub, so we try to discourage that, and there are a few alternatives. One is called Zenodo, which is a European counterpart of GitHub, but does not allow you to rewrite history. So once you submitted your artifact, you can no longer modify it. Of course, we ask authors to write clear guidelines of how to run, how to install and operate the artifact, and how to run experiments. And this could be in the form of a paper appendix that is published in the official proceedings with the paper, or a README file. And some conferences ask both. So at least, so the paper itself in the official proceedings is accompanied by a description of the artifact and links to where readers can find those artifacts and how to run them, and how to exercise them, and how to run the experiments. We also ask them to provide whenever possible, a minimal simple experiment to be used as a running example in the initial stage of the evaluation, what we call kick the tires stage, just to make sure that there are no discrepancies, and to engage with the author, with the reviewers. And from the reviewer side, is easier to have something self-contained and minimal to be run that takes maybe a few hours. Some of these prototypes run for days, right? So if you wait days to obtain some results, and then halfway through it crashed, that's a lot of time wasted. So we encourage authors to provide a smaller set of experiments, or a smaller scale of experiment, but end to end, to be able to find these problems early and quickly. It's only 1 month of the timeline is it's only 1 month of evaluation, so the timeline is short. And finally, like I said numerous times throughout the previous slides, this is a two-way street. We ask the authors to engage with reviewers, and we ask reviewers to engage with the authors. And whenever something is wrong, or there's an update, or authors discovered that maybe they can improve the guidelines, maybe they can improve the scripts, we encourage them to talk to the reviewers, and reviewers the same. This is still a double-blind process. This back and forth happens on a website called HotCRP, which allows anonymous communication between authors and reviewers. And most importantly, and I'll get back to this point, the whole process assumes that authors will continuously improve the artifact up until the final decision, based on the guidelines and comments from the reviewers. On the other side of the aisle, the role of reviewers are to obviously evaluate the artifact, but also make sure that code and paper claims align. If the paper claims that the prototype should have 5 modules, but the prototype actually implements 2, that should be flagged. And authors will be given a chance to explain, but ultimately, if parts of the prototype are missing, the evaluation cannot take place. We always encourage them to start early. Like I said, some of these prototypes would run for days, and we encourage them to engage with authors. Don't just say, okay, this artifact doesn't work because it's missing some Python dependency, or doesn't have Rust installed in this VM. And so I'm not going to award any of the badges, but rather communicate these issues to the authors and give them a chance to fix. And I've been to both sides of the aisle, and I really appreciate when reviewers are telling me, and also a bit embarrassed, but it is what it is. But I also appreciate reviewers telling me that, hey, Bogdan, you should, you should check the script because it's missing a dependency, or it crashes halfway through. Instead of just saying, well, oops, you don't get any badges because I follow the steps, and at step 3 I got a crash, so I gave up. We also encourage the reviewers to follow the chair's guidelines, these are general guidelines, but also specific for each badge. Each badge has a checklist that reviewers go through in order to award it, what are they allowed to ask authors, and what's reasonable to ask and what's not, and in that sense, the role of the chairs is to make sure and to enable and make sure this back and forth process goes smoothly, but also reviewers have concrete steps that they follow to award check the badge. So it's not just a feeling or vibes; it's actually a checklist. And I'm sure for those of you who've been part of an artifact evaluation committee, you know what I'm talking about. I'm happy to get back to this point in the Q&A. And of course, finally, we want reviewers to write a thorough, detailed, and respectful review. Even if they word all badges, artifacts, and prototypes can still be improved. This is the chance of reviewers to communicate one last time with the authors and provide them with hints and suggestions and feedback on how to improve their prototypes. And this reviews will be funneled into meta review, which summarizes the findings and the usage of the artifact, and basically the whole process that the reviewers went through with challenges and how they were fixed by the authors. So it's not to point out to the authors, but rather say, hey, look, these authors were really engaged, and I've been doing this for 5-6 years now, and I think 90% of the artifacts had some issue that was a blocker at one point or another. So if the fact that we engage and then the authors fix the issues and then get back to us, and then we rerun, engage again, and the authors fix, and this whole back and forth is taxing for the authors as well. So this is not to point to the authors, but kind of point to the shortcomings of the prototype, but actually tell a positive story about the authors and the fact that they're engaged and they improve their prototype, and now it's reusable, and also give the community a bit of reassurance on top of badges that, hey, yes, somebody actually went step by step and they identified some issues. Those issues were solved. So now me as an independent researcher that wants to build on top of this prototype can confidently download it and run it. Right. So this is kind of all abstract about the roles and the process itself, but how do we actually evaluate artifacts? Well, we use infrastructure, and it used to be the case that the infrastructure was just individual machines, desktops, laptops, but we highly discourage that. However, nowadays we actually rely on academic cloud infrastructure. Like I said, Chameleon Cloud is one of the sponsors of most of these conferences, and we're really, really happy that they partnered with us. And of course, some artifacts prefer commercial cloud infrastructure because they need more compute power or credits or whatnot. And sometimes they use commercial clouds to do that. I don't know if I guess we have a little bit of time. I wanted to show you a quick demo. Maybe I'll show you a demo at the end if we still have time of how you can use Chameleon Cloud to help, and how I personally use Chameleon Cloud to help me evaluate uh, artifacts and ensure the results are reproducible. And now, as a co-chair of EuroSys, how I'm helping other committee members ramp up on Chameleon Cloud and to use them. So if I exit this presentation mode, I'm not sure I can get back to it. I have a few more slides, and then I'll get back to the demo. Um, right. So there are a few challenges that we encounter. I personally encountered over the years in doing artifact evaluation. The foremost is first and foremost is that we have short preparation and reviewing cycles. It's just the way it is. The peer review process end to end from paper submission to conference talk is quite packed with various deadlines and milestones, and fitting artifact evaluation into this timeline is always a challenge. So we always complain to the general chairs that we need more time, and yeah, sometimes we get it, sometimes we don't. Hopefully this gets solved, but this is more on the organized part. Um, Another problem is with persisting artifacts on durable long-term storage. Most of the artifacts are uploaded on GitHub because it offers so many cool features, and I totally get it. But we also want to encourage authors to save or store their artifacts on repositories where you cannot rewrite history. So basically, you don't go after a conference and change what's been evaluated. You could definitely do that and have an addendum to the paper, but the process is meant to say, well, the badges are given to the prototype version that happened in between paper notification and camera ready submission. So it's a very specific meaning when you get that check mark. And we need more persistent storage, and we also need more flexibility from the authors to upload there, although for the most part they do use persistent and long-term storage. Now with AI and ML gaining more and more traction, we have a lot of papers that, well, not a lot, but increasing number of papers that require specialized hardware. And it's getting quite difficult for academic clouds, and I'm sure Chameleon Cloud is adding new hardware every month, try to keep up, but it's always challenging to keep up with the specialized hardware requests, and sometimes that's one of the reasons people use commercial clouds for this kind of papers. And finally, a pain point that I'm sure many of you will recognize, the most friction you get when you try to evaluate a prototype, research prototype, or when you're trying to install anything off the internet, is setting up, configuring, and installing the prototype. And this takes a lot of back and forth, and takes a lot of time, both from the authors and from reviewers. Now, I cannot show you the back and forth because they're confidential, but please believe me that there are dozens of messages that happen in the first week, and I would say 75% of the time are about these things: environment setup, configuration issues, or some other installation friction. And if you want to read more, some of my colleagues have written a paper about the last 5 years of artifact evaluation at EuroSys, and they have a bunch of interesting lessons learned. So I encourage you to go to read the paper. I personally know Solal, who's in Switzerland right now. He graduated from EPFL with a PhD. We shared not an office, but we shared the same floor when I was in Switzerland. This is another lifetime ago. He has spearheaded this research and a bunch of other cool things related to artifact evaluation. So if you want to learn more about the lessons and the challenges and how the community is trying to address these, please go read this paper. And check out Solal's other work. Right. So if Mark allows me, I'll just briefly introduce a small pet project that I currently have. Like I said, there are many pain points. And one of them, the biggest one, at least in my opinion, and for me personally, is this environmental setup, installation config friction. So I've been thinking about how can we improve this? How can we, if not completely eliminate, at least alleviate this issue? And traditionally, what the artifact evaluation process is a back and forth, like I said, between reviewers and authors, where reviewers start running something and then they hit a snag, they paste log files for the error itself, or they describe the error in this anonymized forum, and then authors get notified, and then they read, and then they try to replicate what the reviewers are seeing, and then they offer some suggestions. And like I said, this is a very time-consuming process and sometimes frustrating, because if you've written any kind of implement any kind of program and you take it from one machine and you try to run it on another, you will know that you may not observe the same things. So when reviewers are saying that they observe error X, the authors try to replicate error X, and in their environment they cannot replicate error X. So it's pretty annoying. So can we do something about it? And the answer is, or at least my answer is, yes, we can leverage the most popular tool that we have at our disposal today, which is AI. And we can team human reviewers with an AI agent to try to do this part of the evaluation: environment setup, config, and make build, right? And then they will communicate with others, which hopefully, or in the future, will still be human, not AI. And it will be much more efficient from the reviewer side. And also agents have this ability of processing much more error information, many more logs than a human reviewer can, and summarize the issue by drawing from multiple sources of telemetry. And to this end, we partnered with Microsoft Research, and we have this broader project called Systems Intelligence, where we try to figure out if agents can, among other things, build prototypes that we humans write on their own without any human intervention, and whether or not they can make suggestions, give feedback, and explain what snags they hit and what went wrong in a way that a human operator can understand and fix. And I'm not going to tell you more about this, but if you want in the Q&A, we can talk. Please check out our if you go on the ACM SIGOPS blog, there is this series called System Intelligence. We've written a bit about it. So check out the blog, check out our posts, and check out this GitHub repository called sys-intelligence or System Intelligence for more details. But the bottom line is that, the artifact evaluation process is, of course, it's ever evolving, and our goal is to mitigate these pain points between that reviewers and authors have. And if we can automate things, yes, let's automate things. I mean, if this could be done with the decision tree, great. If we need something more fancy, then so be it. Right. So if all of this sounds mildly exciting to you, we have some opportunities for the community and for you guys to contribute. If you want to get involved, there is now, today, we have an ongoing artifact evaluation for EuroSys 2026. It starts on February 4th. If you want to get involved and become a reviewer for that conference, we're still looking to fill a few more spots. Please email us at aec-2026@eurosys.org. You can, take a screenshot, or I'm guessing the slide will share the slides with you. And if that's too short of a commitment, that's okay. There are a few other systems conferences that are coming. OSDI and SSP being two of the big ones, and then towards the end of the year, the new edition of EuroSys for 2027, and ASPLOS is in there somewhere as well. And if you want to learn more about the system intelligence and how you can use how we can leverage AI to improve the artifact evaluation process and make it more fair and more engaging for both reviewers and authors. The same. You can contact me, of course, but I encourage you to drop by the GitHub repository and search for the specific benchmark for that. There are some guidelines in the README. If you cannot find it, just shoot me an email, and I'm happy to answer more questions in the Q&A session. And on that good note, thank you so much for listening. I'm happy to take questions, or if people still need a little bit more time, I can go through a demo. I don't know, Mark, what do you think?
Yeah,
Oops.
thank you, Bogdan. It looks like we have quite a few questions